Greetings to Dr. Dayang Salani and Sek Khairul. We are from Group 2. Would like to present our proposal on open-ended laboratory experiment.
For this open-ended, our group has selected Task B, which will cover on the study about the absorption rate of methylene blue dye on activated carbon and compare the experimental result with absorption isotope models. The methylene blue dye is known as a cationic dye, which typically exists at a large scale in textile, plastic, and dye industry wastewater. Dyes cannot be easily removed using the conventional wastewater treatment processes due to the complex structure and synthetic origins. Due to this, the removal process of the contaminants will be done by using the adsorption method, which is known as the one of the physical chemical method. And the advantages of using the adsorption method is it is known as the most simple and economical techniques, and it has a promising method in removing the dye pollutants from the ecosystem completely. The adsorption process typically being done by utilizing the activated carbon as the adsorbent due to their high efficiency in removing the contaminants. Typically, the activated carbon can be obtained from materials that have high carbon content like coconuts, pea shell, rice husk, corn husk, and woods. And in our experiment, we have decided to use pea shell as the source for our activated carbon preparation. And the advantages of using pea shell as the activated carbon source is it is easy to obtain and low cost material. It also has high carbon content, which is 70.67% of carbon. It also has low moisture and ash content, which is 9.39% and 5.69% respectively. And after preparing the activated carbon from the pea cell, the removal of methylene blue dye in the ecosystem will be further evaluated by using absorption isotope models, which is Lamio and Franley isotope models. The Lamio isotope is assuming the absorption takes place at a specific homogeneous site within the adsorbent. Meanwhile, the Franley isotope is an empirical model which assuming the absorption takes place on heterogeneous systems.
Our experiment consists of three objectives. Firstly, to prepare the activated carbon from pea shell, and next to analyze the performance of activated carbon in removing methylene blue. Lastly, to analyze the experimental data by using the Lamure and Freundlich models of adsorption. In order for us to achieve the objectives of the experiment, our manipulated variables will be the contact time of activated carbon in the methylene blue solution and the concentration of methylene blue. The dye removal rate will be the responding variables, and the amount of activated carbon will be constant throughout the experiment. So at the end of the experiment, the removal rate of methylene blue is expected to be increased with the increase of contact time between the activated carbon and methylene blue solution, but it will decrease with the increase of initial dye concentration, which is methylene blue.
Next, I will present the methodology that will be used by our group for the open-ended lab. The process flow of our methodology is started with the preparation of methylene blue solution, followed by the preparation of activated carbon, and then the absorption experiment will be performed, and lastly we will do the kinetic study based on our experimental data. For the preparation of methylene blue, the dye stock solution is prepared by dissolving accurately weighed dye in distilled water to a concentration of 500 mg per liter. The experimental solution is obtained via the dilution of the stock solution in accurate proportions to different initial concentration.
Next is the preparation of activated carbon, which is obtained from pea shells. So firstly, pea shells are being repeatedly washed with distilled water to remove any dirt, dust, and other impurities. The washed shell materials are then being dried in sunlight for approximately 2 weeks. The chemical activation of the pea shells is being carried out with zinc chloride solution. Then, 10 grams of dried pea shells are being well mixed by stirring with 100 ml of an aqueous solution that contains 20 grams of zinc chloride. The mixture is then being heated at 80 degrees Celsius for 1 hour. After the heating process, the slurry is kept in an oven at 100 degrees Celsius for 24 hours. The resulting zinc chloride treated sample is then subjected to carbonization and activation process by using electrical furnace at 500 degrees Celsius for 1 hour. So after the activation process, the sample is then being allowed to cool down and subsequently washed with hydrochloric acid before being washed with deionized water for several times. And lastly, it is being grounded into a fine powder.
This is the procedure of the adsorption experiments, which is started with the preparation of methylene blue solution or the dye solution in a series of 250 ml Allen Mayo flasks with different initial concentration at pH 6.5. And then 0.1 gram of activated carbon is added to every dye solution that are prepared with different concentration. The flasks are placed in a thermostat water bath shaker with the agitation speed of 150 rotation per minute at a temperature of 25 degrees Celsius, and the duration set is 200 minutes. The aqueous samples are taken at present time intervals, which is every 20 minutes. The activated carbon is separated by centrifugation for 10 minutes at 3000 rotation per minute to avoid interference due to the carbon fines. The residual concentration of methylene blue is determined by using UV spectrophotometer at a wavelength of 668 nanometer. All the kinetic experiments were carried out for different dye concentration at 25 degrees Celsius. All the data is recorded and the calculations are performed using the formulas provided. And then the experimental data will be analyzed using the Langmuir and Freundlich models of adsorption. These are the formulas that will be used in the calculation parts in our study. The first formula is the percentage of removal, CO minus CT over CO times by 100, where CO is the initial concentration of methylene blue, CT is the concentration of methylene blue at time t. The second formula is the amount of adsorption at time, which is QT. The formula is CO minus CT in bracket times by V over W, where V is the volume of the methylene blue solution and W is the weight of adsorbent.
For the last part, I'm going to present the safety precaution during and after preparation of methylene blue solution and activated carbon as well as adsorption experiment. As usual in the labs, lab coats should always be worn when performing laboratory experiments. Then we must wear safety glasses or face shields whenever working with equipment, hazardous materials, glassware, heat or chemicals. Next, we should also always wear the appropriate glove when handling toxic or hazardous substances. During the preparation of methylene blue solution and activated carbon, we must use heat-resistant hand gloves to pick up the crucible from the furnace and oven. We also need to avoid contact with eyes, skin, and clothing when handling chemicals such as zinc chloride and hydrochloric acids. Next, methylene blue solution must be kept away from heat because it is a flammable liquid and it must not be inhaled. After the preparation, we must wash our hands and the chemical waste that is produced must be poured into the container that is provided in the lab. The solid waste, which is the pea shell, must be thrown away into the waste bin. Next, during the adsorption experiment, when handling the activated carbon, avoid producing dust. And if there is the presence of dust or the dust is produced, the dust must not be inhaled. Therefore, to avoid inhaling the dust, we should or we must wear a mask. Similar to the safety precaution during preparation of methylene blue solution, the dye solution or methylene blue solution must be kept away from heat because it is a flammable liquid and it must not be inhaled. And last but not the least, after the experiment, we must wash our hands and the chemical waste produced must be poured into the container provided. That is all from our group. Thank you for listening and have a nice day.